Recording here, so just in case anybody misses this, really appreciate everybody joining again for installment number 2 of the Mastrena II webinar series. Let's see, next week we're off. The following week we'll be doing the PM best practices, going through some ways that we can streamline the PM for you guys and make it easier for you in the field. And then the following seminar after that, 2 weeks later, we don't have a topic for. So we'll be sending out another survey at the end of this. Please respond and let us know what you think would be a good topic. Or when we get to the Q&A session today, feel free to chime in there to let us know what you want to learn about. We want to make sure that we're not just showing up telling you what we think you need to know, but also trying to make sure that you are learning the stuff that you want to know about in the field. So today we're covering the Brew Chamber Heater circuit. We know this has been a sticking point for lots of people, and it's been frankly a struggle. I think every machine always has its Achilles heel. Right now, I think this is one of them for the Mastrena II. So we don't have a full resolution yet, but hopefully today we can give you some tips and tricks on how to troubleshoot appropriately and make sure that you're making the correct decisions out in the field and replacing the right parts when you're out there. So, so with that, I think I'm going to kick it over to Paul. He'll start off with talking to us a little bit about how we start the troubleshooting process when we have a brew chamber heater problem, usually with a boiler controller error that's associated with the brew chamber heater. So go ahead, Paul.
Thanks. Good morning. Good afternoon. Those of you on the East Coast. Like Nick said, we know we have a lot of machines that fail with this error and boiler controller error. And a lot of times we see that the cause is from a failed brew chamber heater, which some of you probably recognize, see it like this, and causes the machine to either just not work because it doesn't heat, or in some cases we walk into the store and we see that the machine doesn't have any display. The power switch is illuminated, but the main UI is blank. So how we start testing that is if we have a blank display, but the switch is illuminated, then we always want to see if our fuses are good. Right? If our fuses go out, they carry L1 and L2 through the machine. So if the fuse is out, then we won't get any reaction from the machine. So I have a power board here.
Gotcha.
Thanks, Nick.
Yep.
And sorry, I do not have a full machine with me, but you know, if the power board is sitting in the machine, we would test our fuses here. So before we remove the fuses, before we touch any of this, please make sure that you power the machine down, unplug it if you want to be really safe, but we don't want to touch these with the machine on and live. So we would simply test the fuses. I'm sure everybody here knows how to test the fuses, but I'll walk through it anyways. Set our meter to continuity, make sure that we have tone, and I typically put an alligator clip on here just to make sure that I don't get a false reading from touching my meter like this. So I'll just hold one end, test it. If it tests bad, then we would need to replace it, and we'd go through the same process on the second fuse as well. Once we know we have good fuses, before we turn the machine back on, we need to find the cause of that fuse failure. Otherwise, we're turn it on and we'll just blow these fuses again right away. So what we're talking about today is these failed brew chamber heating elements. So let's say that the cause of the fuse failure is a heating element, then here, I know it's kind of hard to see. It's not the greatest video quality, but our heating elements connect here and here. So if the machine is warm at all, then we want to let the heating elements cool down because the resistance is going to change as the temperature changes. So what I suggest is just pulling the heating element out of the machine, letting it cool down for a few minutes, make sure that it's not hot to the touch, and then we can start to ohm and test. So on our troubleshooting guide, we have here what all of our resistance readings should be throughout the element. So we can see here, we should be reading 1 k ohm between pins 1 and 2. So pins 1 and 2 are here opposite of the clip. So here's our locking clip here. So pins 1 and 2 are opposite of that. So we have our meter here. We come in on 1 and 2. Oops. And we see we're around right around 1 K. So that would indicate a good heating element. Then we would check our NTC, which is pins 3 and 4, and we should be around 10 K ohms on that heating element. So again, we'll come here. Test pins 3 and 4. Let our meter settle. I'm around 11 K here. So I'm not quite 77 degrees here in my house, so that's why I'm not exactly at 10 K. And then last, we want to look to see if we have greater than 10 mega ohms between pins 1 and 3, 2 and 3, and 4 to the housing. So what we're looking for here is we just want to make sure that we don't have continuity between the low voltage side and the high voltage side. If those short out, then typically that can damage the CCB. So here, I'll set my meter back to continuity, and I'll make sure I do not get tone between those. I don't have a heating element here that is actually failed that way, but again, if you do get tone there, then it's shorted between high and low voltage and possibly a damaged CCB. And of course, if any of those tests fail, then we likely have a faulty heater, or if you have a physically damaged heater, such as this, there's no need to ohm this out. We would just replace it.
Paul, did you do the continuity to the case also, to the cartridge itself?
So for that,
yeah.
I just put my alligator clip back on. To the case. And I just want to make sure that I don't get a reading and that I'm not shorted to the case.
Yeah.
So all of it is OL, open line or open loop, and make sure that we don't have something funny going on inside here with the wiring.
Yeah, many of you guys have probably had a hydraulic heater or a steam heater that is cracked, and then it shorts through the water to ground, and so you get a constant heating situation. A similar thing can happen with this brew chamber heater. If it's shorted through the case, you can get a slow leak of current that will cause it to constantly heat and could create an overheat situation and pop your fuse. Cool. Thanks for that, Paul. Any questions on testing the heater before we move on? Great. I will switch this over here to my machine. Never mind the piston error and other things. I don't have a module in the machine. And that's why it's giving all these errors. So first thing we're going to do is we're going to log into service, just like you normally would, with your USB stick. And then, of course, take your USB stick out and put it back in your pocket so that you don't leave it in the store. We'll go to System Settings, Machine Test, and Component Test. Never mind the screaming in the background. She's fine, I promise. And we're going to go, you'll notice that over here, the brew chamber heater NTCs are both reading a -1. Anytime we have an open circuit for an NTC on Mastrena II, it will read in the software as a -1. So we don't have any NTCs in here right now, and that's why we have -1. So we're going to go to our second page here, and we're going to test brew chamber heater 1. So we'll lift the hood up. Let's get a little bit more light in here too for you guys. So we're going to look in our training guide here. We are looking for this connector here, number 3, which is XM4. Or I guess it's XM5. This is a typo manual. It's an old one. And so if we look at this connector here, we start with 1 and we count to 25. These are our references, right? So 20 to 25 is down here on the bottom. And we're going to be looking for pins 21 and 22 down here. So again, we count 20 to 25. So we're going to go 21 to 22. And you'll notice on the meter, we have 70 volts AC. That is a ghost voltage because we use a triac to switch rather than using just a straight switch. We get a little bit of ghost voltage there, but it's nothing to worry about. It's not actually 70 volts of power going to the heater. So then we will activate our heater. And we're getting 239. It's my office, so I don't have 208, I have 240. So we're testing good for our circuit here. If we didn't have voltage there, the first thing that we would want to check is that we have a light on our power board. Let's see if I can get a decent shot of this here. So if we look down in that little cavity there, we can see that the light does turn on. If it didn't turn on, we would be looking for an issue with our component control board or the connection between the two. But if we did have a light, we could potentially have a failed triac on the board. So I will kick it back over to Paul to show us how we test for a failed triac on the board. There's no questions, right, about testing that circuit to see if there's high voltage getting there? Okay, great. Go for it, Paul.
Okay, so on our power board, we've got these opticouplers here. There's one opticoupler for every triac. Right, so we've got 6 opticouplers here, 6 triacs here. These 3 opticouplers are by themselves, but these are for the 3 triacs that are on the chassis for the 2 steam boiler heating elements and the hydraulic heating element. So what we're looking at here, this track here, which is labeled as 17, is the track for the brew chamber heating element number 1. So this board, I got this board from a tech that failed in the store as having continuity. It was constantly giving power at pins 21 and 22 that Nick just showed. And no matter what, even though the CCB was not telling brew chamber heater number 1 to heat, it was still supplying power, and the temperature on that brew chamber would just keep heating. So just want to show how we can test this. Is there a way we can test a triac? If it's failed close, yes, we can. So I don't recommend doing this in the store. I'm doing this just because the board is already damaged. But if we kind of bend these out of the way, you'll see that the triac has 3 legs, right? Just like the larger triacs. There's a A1, A2, and gate. So if we flip the board over, and again, I'm sorry, I can't zoom in on this platform, but A1 is here, A2 is here, and gate is here. So this is the track for brew chamber heater number 1. If I touch my leads here, I do get continuity. So I should not get continuity. Like the rest of these are good. See, there's no tone here from my meter, but this one is bad. So if you test that, basically if you're getting the 208 at your pins, but the LED here is not illuminated, which it's kind of hard to see, but the LED is right here, then you can always just test this. If you get tone just like this board, then the board is bad. And again, we don't replace anything on the board other than the fuses. So if the board is bad, we just replace the entire board.
Thanks, Paul. Any questions on that?
I got a question.
Yeah.
We've been told, and when we have a problem with NTCs, it'd be a good idea to change both NTCs or both heated cartridges, and also change the component board and the power supply board.
Okay.
Is that correct?
Well, and so this is exactly why we're having this seminar, is to show you guys how to go through and test each component. So we recommend you replace those components if they test failed, right? Okay. So if your brew chamber heaters had failed any of the tests that Paul went through earlier, or your fuses are bad, for example, or the power board has a shorted triac like Paul just showed. And then right now I'll show you guys how to test the component control board also. But we recommend making sure you test everything before you replace, so you're not just replacing components to make sure that the problem is solved, right? If you've tested everything and it's passed, then you can know which components are failed and which ones are good.
So what you're saying is we had a situation like this already, or 2 situations like this already, and where we changed just the cartridges, and then we had to go, and it works fine for a week, and then we had to go back and it failed again. And that's what we've been told. Well, it's better if you change this and this and this, and that way you prevent service call going back. So in this situation, like I said, the machine keep working for a week. So that means then the component board and also the power supply board were working properly, correct?
Should have been, and this is why we're testing now, is to test those components to show you how to do that.
Okay.
Cool.
Yeah, and I would make sure to notate that in your resolution notes. Say, I tested the pin connectors, I had no power there. I did not have an LED on the power board unless I activated, kind of just detail of how you tested it. That way, you have everything there in a paper trail.
Mm-hmm. Yeah. Nick?
I got a question. I had one. So is it possible for that triac to fail intermittently? Because I feel like that was the one that is what happened to me a couple of weeks ago. We replaced the heater, everything worked good. And the next morning they called back and it turned out to be the component board. Everything else, the heater seemed to stay fine. It just was stuck closed, so I was getting a constant power to the heater. But it didn't seem to do that after I just replaced the heater.
It's possible, but it would be challenging to test, right? So I don't think that means replace the power board every time. Like seeing it once doesn't necessarily mean that all power boards are bad, I think is the key message here. So.
Okay, thank you. I just wanted to, throw in that it seemed like maybe intermittently it is, so you're not replacing everything again, that it could have been just, another heater or the board.
Right, yep, it is possible. All right, let me show you guys really quickly the testing of the component control board. So our CCB sends the low voltage signal to the power board to activate the optocoupler to close the triac to allow power to your brew chamber heater. So we're looking at, let's see, connector 15 here. See if I can get this in here right, which is the output to brew module left. And we're going to be looking for our oh, sorry, wrong one. I'm looking at the outlet to the power board. My mistake. Yep, number 15. So we need to be looking at pins 8 here, and then pin 10, which is your power supply zero crossing. In this case, let's just call the power supply zero crossing a ground. It's the negative. The way that optocouplers work, they use half of the wave of the DC to activate. So if we look here at connector 15, we start counting from the bottom, pin number 1. And we need pins 8 and 10. So number 1's at the bottom. That means that number 10 is at the top. And number 8 is this pink guy right here. So we put our leads in there and we get a good connection. See, we have negative 11 volts DC, because right now we're reading the lower half of the DC wave. When we activate, we should get 12 volts DC that leaves that to activate the optocoupler on the power board. Now, the other thing we could test, or at least look at, is our number 16, which is our output to brew module left, because it has our brew chamber heater NTC and the NTC ground. So we're looking at connector 16, again, starts at 1. And we want pins 5 and 6. We're gonna do 1, 2, 3, 4, 5. It's yellow wire. 6 is black. We should get our 3.3 volts DC. If we aren't getting voltage there, that means our CCB isn't sending a signal to the NTC. Now, I have seen cases, particularly on Slack, where that connector on the board is smoked because we had high voltage that fed back through the NTC circuit to the component control board. So that's another thing to make sure you're checking for, is take a look at those connectors and make sure nothing's black there and burned. Because we have high and low voltage in that brew chamber heater cable, and it moves back and forth, and we can end up with cracking that can cause some failures in there. So that's how we test the CCB. Any other questions, comments?
I have a question again.
Yeah.
In that particular case, and I mentioned that we have to change the 2 boards and the 2 NTCs. We got help from one of the techs, and we did that particular test in UHSD right now. And all the readings were properly, and the NTC is still not getting power. And we did those 2 tests in UHSD right now, and we got all the proper readings, but it's still not same signal to the NTC. So that's when we had to change again the board and the power supply board, and after that it worked properly.
If you had 3.3 volts DC at your component control board,
Yes, we
then you
did.
probably had, I would guess, a wiring problem. That was then, yeah, this is Jet, by the way, something, a loose connection, loose pin connector, something like that, that was a problem until you put the modules back in.
Well, yeah, we changed the boards at the time. We had changed prior that the HSD CC board, then you test. And after the testing and get all the good results and still not working properly, so that's when they say, well, change again the CC board and also the power supply board. So if it was a loose wire, I mean, I kind of doubted. Then when we put it back together again, the other board, we kind of fixed the wire.
Yeah. Since I wasn't involved in that one instance, I can't tell you where the problem was. But please do not replace boards without testing that they're bad.
Well,
it's very, very expensive.
In this situation, since we got the 2 writings,
Yep,
properly,
yeah, and I can understand the logic there. But
yeah, how can I
for everybody here, please do not replace boards unless it's tested somehow that it's failed, or you've had a discussion with a tech support person, like you said, to replace the board.
Okay.
Other questions?
And real quick before we move on, I just want to show Nick's meter had these really thin leads. My meter doesn't have that. My meter leads are regular size, and sometimes these are too fat to get inside of those harness connectors. So I picked up these needle lead extenders. I think they were $9 on Amazon, but they will save you a lot of headache because you can get into these different connectors and get true voltage readings. Because I know sometimes if you come in here with just the standard, you can activate things and say, oh, I'm getting 0 voltage, I'm not getting a reading, but in actuality, just your meter wasn't in all the way. So if you don't have some of these or leads like Nick has on his meter, then I would suggest definitely grabbing some of these.
Agreed. We have Todd asked a question here in the chat. Brew chamber heats when an advanced test. What failure is that revealing? So CCB or power board or only brew chamber heater. That sounds to me like what we were talking about when you have one of your legs shorted to ground and you get a constant heating situation. Anytime you're in the test menu, the brew chamber heater should not heat unless you are activating the heater. But maybe I read the question incorrectly, but that sounds to me like it's if the heater cartridge is shorted.
Yeah, I would also look at the LEDs in the power board because that's going to tell you which way. And then again, you could do that test that I did where you tested the triac. If you get tone there, then that means that the CCB is not sending the signal, but the triac is locked closed and it's going to continue to supply power even when you're logged into the test mode.
Yeah. Thanks, Paul.
Is there a way of testing that triac to where it doesn't energize? Can you energize that triac with your multimeter?
No.
No.
The best way to test that would be to activate it in the test menu and test for voltage either coming out of your power board or test for voltage at the pin connector at the back of the machine.
All right, thank you.
Yeah. And then Brad, you had a question?
Yeah, just on the failed triac, if it's constantly sending voltage, are we going to see probably an LED always, or not necessarily always a lit LED?
You would not see a lit LED. The LED is what activates your optocoupler. So it's actually the light from that LED that closes the optocoupler that then closes your triac. So if you have a failed triac, your LED won't be involved at all. It'll just be the triac that's closed. iPhone, there's like 6 of them, I'm sure, but somebody said, sounds like you still have to check the boards with a meter. And then Todd says, -1 degrees on the brew chamber heater indicates a missing brew chamber NTC circuit. Yes, you basically have an open circuit for the NTC. If the power board can't see, or the component control board can't see the NTC, it will give a -1. And then Kenny asked if this is available for print or downloadable. We're working on a little print walkthrough, and then there will be a video also that's posted on YouTube. We'll get a link posted to My Thermal Plan for that as well. That steps through all this stuff too. Any other questions related to the brew chamber heater? All right. Any other just general questions? Mastrena II related.
Yeah, this is Glenn, St. Louis.
Glenn?
Hey, Glenn.
Yeah, I posted on Slack, I guess, about 3 months ago. I had a instance where the machine was dumping water all over the front of the machine. And what had happened was the channels in the drain tray had warped upwards. And when you push the drain tray in, it was pushing the drain valves backwards. So they were draining off down into the machine. Anyway, I just got a call back the other day at that same store. And this time the other machine, same thing, although this time it was only the left side drain channel. And it was rather unusual. The plastic, I was actually able to, this plastic was so soft on that drain channel, I was actually able to bend it back down into position, although I did change that drain tray, that insert. I don't know whether that's an issue or not, but the one thing I did notice, and this has been on both of those, was when I pulled that drain insert out, there was coffee residue, water, and milk trapped down there underneath that, and there was mold. And I know it was worse on that other machine, but there was definitely mold growing down there in the milk that had gotten down in there. And I'm just wondering if that's an issue or something that maybe needs to be looked into. I don't know. Something I saw, probably wouldn't be too good of a thing if this was happening in a lot of these machines and it was just sitting there, because there's really no way to clean that other than to take the insert out of there and clean it out. But I just wanted to bring that up, something I've noticed now twice.
Yeah, thanks, Glenn. I think I saw pictures of one of those a little while ago. But yeah, we'll keep an eye out for it to see if it becomes a larger problem. I think yeah. So if I understand you correctly, basically the little cup that's supposed to catch things out of the drain valve had bent up so that when they put it in, it pushed the drain valve back. Is that right?
That is correct.
Okay, cool. Just to sort of log in my memory bank to see if it keeps showing up.
Yeah, I wonder, because I know the SCEM says to put those things into the sanitizer, and I thought, well, maybe they were putting it in such a way that there was force being applied to those channels, and then the heat was causing them to warp upwards. And I kind of coached them to don't do that, but I don't know. It's just that one story. I haven't run into it anywhere else.
Okay. Looks like iPhone says it's happened before too. Other questions? Sherry, you said low water flow issues. I think you're muted, or we can't hear you for some reason. Nope, still can't hear you. Is it just me? Okay.
No, I don't hear her either.
Yeah, Sherry, we can't hear you for some reason.
Hey, Nick, can I bring up the question I raised in Slack regarding...
1 second. Let's see if Sherry can. Yeah, let's do your question and we'll come back to Sherry. Maybe her audio will work a little later.
Okay.
Go ahead, Matt.
So I posted in Slack, I don't know, 10 minutes ago, about 2 units that I have, 2 separate sites. Both were PM'd recently within 1,000 shots. And what is happening is it's giving a flow error midway through phase 1 of the cleaning cycle. And both machines I observed while open and cleaning, I found that the right side brew chamber pressure would start to drop off after about 4 or 5 rinses of that first stage. And it would slow down to about a trickle. I took apart the outlet valve and the drain valves and made sure that they were installed properly and put together properly. Everything's fine with those. But I did notice after I put them back together, pressure seemed fine after that. So I kind of chalked it up to a possible intermittent failing outlet valve. So I ended up replacing it and seemed to work fine after that for both of them. But now they're calling it back in again today for the same exact issue.
Nick Boland, didn't you have an issue with the outlet hose that when it heated up, it would kink on one side and you would have that problem?
Yes, and it would happen after about on like the 3rd shot or say the 3rd rinse, and it was always Brew Chamber II. Because if it sat there for little like 30 seconds, it was enough to cool off that would give it enough rigidity so you could pull 1, 2, maybe 3 shots, but definitely that 3rd, 4th, or 5th shot, it would just collapse again and kink.
Okay.
I've had it probably about 3 times now.
Do you think maybe sticking a spare piece of hose on the outlet valve and kind of testing that way would be a good way to go about it?
Yeah.
Okay. Thank you.
And what he just mentioned was probably the last machine that I was suspicious of that happening. I did just use a tube that wasn't connected to the outlet itself and ran 3 or 4 shots and felt comfortable that it was a kinking scenario again instead of anything else, because I could pull 10 shots in a row and it was fine. And to test that, I talked to a technician yesterday about that. I said, just pull straight decaf shots. So that way we're kind of hammering Brew Chamber 2 instead of, giving it that chance to cool off a little bit. And he never called back. So either I was right or he called somebody else.
Okay. I haven't really tested it with like straight decaf yet. And when I calibrate shots, I alternate between the two brew chambers. So I'll give that a go this time around. Thank you guys.
That was all assuming that all your other brew paths are clear and everything seems fine, right?
Yes, it was just
okay,
PM'd within the last 1,000. So everything's super clean.
All right, that's what I thought. Thanks. Any other questions? Sherry, is your audio working now? Darn it. I wish I could read lips. Anybody read lips? Can't hear anything.
The mute button's in the lower left-hand corner of the screen if you're on the computer.
Well, no, she's unmuted. It's just for some reason the audio connection isn't working on her phone. Low water flow. Just in general, how do we troubleshoot that? Is that what you're wanting to talk about? Okay, so that is actually probably a really good topic for another seminar. Okay, cool. We'll make a note of that. Todd says that a machine that made uneven pucks that were thicker at the top mean that your machine is upside down. So gravity is taking the puck, the coffee to the top. I don't know. I don't think I've spent enough time observing pucks to know. Was there another symptom or other problem?
I think
Todd, was there any of that?
Go ahead, Paul.
Was there any of the puck stuck to one of the pistons that it just broke apart uneven?
Shots were inconsistent and had double pucks. Sounds like a blockage or clogging to me. Somewhere in the screen or the piston.
Yeah, it sounds like a bad screen to me.
Mm-hmm.
Clog screen, I should say.
Yeah.
Or double screen.
That's a possibility too.
I have a question about drain lines.
Yeah, go for it, Nick.
So I've had not very many, but a couple of clogged drain hoses, and it usually where it tees off the first time, if you follow the drain line from the drip tray, the first right-hand turn that it makes, it gets clogged right in there. And some of the machines, I noticed that drain line in between those two T connectors, some of them it loops up and some of them it loops down. I was wondering if there was a preferred way. It seemed like the loop down would keep at least that first T a little clearer.
Yeah. Preferred is straight, actually. Sloping downhill, right? Because that's how drains work. But yeah, maybe you can sort of push them together a little bit better and make it not have a loop in it. I don't know. Okay. We do know that the drain system is not ideal. And so it's on our list. We've got some other things that are ahead of it, but it is on our list of things to look at. Jeff sent a message saying had issues with hopper magnets. Can you give a little more detail about what type of issues with hopper magnets? Yeah, throws a grinder error, right? So, I mean, if your reed switch can't close, then your reed switch circuit, or you'll get a safety stop error, right? Or your grinder won't work, brew chambers can't move. So, yeah, I don't know. Yeah, it's replacing the hopper and it's fine. Yeah, sometimes that can happen, I guess. It's happened a lot. Yeah, okay. All right, any other questions?
Hey, on those drains, it would sure help when they did the installs if they would put the access holes on the counter at the back right of the machine where they're supposed to, instead of kind of wherever they want to. Because I've run into maybe one install that where the hole was there at the right. If it was at all of them were at the right machine on the right hand back corner, the drain would work so much nicer than having to loop back and go back through a hole that's on the left side of the machine, and then it's just something I've run into.
Yeah. Yeah. Oh, well, and then once you get it set up, the store partners might move it. So you never know what'll happen.
Yeah, that's true too.
Yeah. All right, anything else? Any other thoughts for topics for future? We've got the low water flow. Anything else?
Real quick, as Nick mentioned at the beginning of this, 2 weeks from now, our next seminar is going to be on PM best practices. So please let us know what you would like us to cover in that, so that we can be prepared and have everything covered that you guys want to see and what you guys have questions on.
You can use the general channel in Slack, or you could respond to the US training email also to give us those thoughts. All right.
A kind of funny question.
Sure.
It probably sound maybe stupid. So, you know, the
questions.
new machines, the new M2s, the new M2s, when we need to change the clean assembly, on the new ones they put the holes for the screws, so that makes it more simple to remove those screws on the cleaning and remove it. Do I say it's funny and stupid? We were thinking on the old models can we make the holes ourselves?
No. You could order the panel.
Oh, okay.
To replace the panel if you wanted to, but it's a few extra screws to get that side panel off and then replace it. I would say it's probably not worth the risk of drilling holes in the aluminum.
Okay.
So
all right,
yeah,
man.
I'm sorry about that. I'm sorry we didn't catch that before we produced a bunch of machines. So. Any more questions? We got 9 minutes left.
Lube on the cleaning key assembly seemed to be a hot button topic again on Slack the other day, I noticed.
Yeah. So I guess I can tell you. We're working on a change of the O-ring itself. We'll make it 1 millimeter smaller. That will help to prevent this issue. But we're still a little ways out from being able to make that change. So in the meantime, sorry, use lube, don't use lube, whatever seems to work best for you. But we're working on it. The 1 millimeter difference, actually, what happens is the O-ring will pinch when you're trying to turn it, and then it gets stuck. The 1 millimeter smaller seems to prevent that from happening. So we're working on it. It's coming.
If
Okay.
in doubt, replace it.
Yeah. It is also a storable part. Whether the store can actually order it and receive it is another question, but yes, it is technically storable. Anything else? Yes, Nate, that O-ring will likely ship with PM kits once it changes to get it out into the bearings on the steam actuator valve. Can we discuss that, Paul? So make sure we cover that, how to remove those bearings.
Yes, absolutely.
Cool.
And can you hear me?
Yeah.
We can.
Yeah, another thing for the PMs, if you guys could show how to properly drive that guide sleeve, PAP, the PAP, so that it goes in evenly on the brew chamber. I've had a few where if I don't line it up just right, it makes the mobile piston not slide right. And so best practice is on driving that in straight.
Cool.
Yep.
Hey,
Do that.
hey Paul, if you're gonna do that, just make it real, because in the video, then you guys have to remove those little white things. I mean, he pulled it out with his finger. You cannot pull it out with his finger on the PM. I mean, just make it real, please.
Yep, I have, there's a tech here local to the Southern California market. He actually bought a tool, made a tool himself from a couple parts he got at Lowe's that helps drive that out. So I will cover that in the next video or next seminar for sure.
And then Todd's asking when we'll get the 6.4 check valves available. You can order the 6.4 kit from TPD, just not the individual valve right now. Has to do with some item setup challenges, I believe. But you can get the 6.4 valve just as the whole kit. All right. Anything else? Thoughts for PM best practices? Gripes, complaints? We're here. All right. Going once.
Yeah, I just had the one there, Nick, on the small screws for the cleaning key assembly. I struggled with those. Those were very hard to get in. May have been just that it didn't have quite the right screwdriver, but it seemed like they need a bigger head on them.
You know, it is a good possibility that it's called a Posi-Drive screw, not a Phillips screw. I wish I had one here. Oh, do I? No. But maybe I can try to show you anyway. So this is a standard Phillips screw. It's the one we use to close the hood and all that kind of fun stuff. A Posi-Drive screw has a little notch right here, like a little line next to it. And what that means is that instead of just being a star pattern, it's got this extra little notch in between them. And so if you're trying to use a standard Phillips in it, your chances of stripping it out increase pretty greatly. So make sure you're watching your screws to find out if it's a Posi-Drive or a Phillips. It's a common challenge with machines designed in Europe. They use the Posi-Drive instead of Phillips.
I don't have one for the cleaning assembly that you're talking about, Brad, but here's a Posi-Drive. It's the same as what's on the mobile piston to keep the brew chamber heater in place. And also the cap on the mobile piston. That's a Posi-Drive.
Yeah, so it's just got a little, instead of just a cross, it's got a little notch over here to indicate it.
Gotcha. Okay. I must have noticed it.
Yeah.
Tiny. Get a microscope.
There you go. Okay, anything else? For PMs, we must do settings. Oh, how to initialize the grinders. Yeah, we can cover that as well too, Nate. How to sort of restart the machine and initialize the grinders and calibrate. Is that what you were mentioning? You meant by that, Nate?
Hey, can you hear me?
Yeah.
Hey, how's it going?
Good.
So I mean more so like just so our techs know like when they do PMs what exactly they need to do. Because a lot of them know how to do that stuff. It's just like they don't necessarily know, like when they do the PM, they forget at the end like that they have to do that or something.
Right.
And then we get tech support calls. So more so like what exactly that kind of stuff that has to get done when you do a PM.
Okay.
Thank you.
So like the finalizing steps, calibrations, things to check, that kind of thing.
Yeah.
Okay. No problem. All right. What was that, Caleb?
Yeah, just wanted to point out for the lube, it's in their skim in tools and parts, not in Mastrena skim. So if you're trying to explain to them how they can order that, that's where they would go, tools and parts skim. It's separate from all the other equipment skim. So just wanted to throw that out there because I know that's been coming up a little bit when you're trying to coach them that they can use the lube. The food grade Taylor lube, that is.
Awesome. Thanks, Caleb. All right. Well, that takes us to time. Really appreciate everybody's time. Again, if we had a slightly lower turnout this time, so please tell your friends that we wanted to send the invite not as just an Outlook invite, so it would have a sort of different look and feel. Also be able to reduce the number of people who could be seen in the 2 box and that kind of thing. So tell your friends, and you know, we'll see you in 2 weeks to talk about PM best practices. Thanks, everybody. Appreciate it.
Thank you, everyone.
Thank you.
Talk later.
Thanks, gentlemen. Appreciate it.